phase voltage are 0. Of all phase voltage is 0. So this is the condition for a system to be a balanced system. Okay, now let's take the example of unbalanced system. Okay, so let's see what are the example of unbalanced system. Unbalanced system, unbalanced supply of system. Okay, now so a supply is said to be unbalanced. A supply is said to be unbalanced either its magnitude are unequal or its angle are unequal or both. So I just take first example, then you will write it. V angle 0 degree, VB angle plus 90 degree, and VC equals to minus 120 degree. Similarly, I can write next example, VA equals to V1 angle 0 degree, VB equals to V2 angle minus 120 degree, and VC angle V3 angle plus 120 degree. So let's see what are the main concept. Here magnitude are same, but angle are different. So it is unbalanced supply. Okay, now in that case your angle are 120, but see the supply magnitude are different. So a supply is said to be unbalanced. I will write here a supply, just write a three-phase supply is said to be unbalanced when either the magnitude or angle or both are different. So these are some example. Now I will take just practical example of supply voltage. So if you see three-phase generating and transmission voltage are in general balanced, but three-phase distribution voltage are unbalanced. That means distribution system there is more unbalancing. So this is about the balance and unbalance, and you can take the other condition, VA phasor plus VB phasor plus VC phasor is not 0, then it is unbalanced condition. Hopefully ये बात समझ में आ गई होगी. So this is about the first point, the balanced and unbalanced supply. Now in the next part we will see the balanced and unbalanced load. So let's start the balanced and unbalanced load. So we have discussed the balanced and unbalanced supply. Now the second part of the basic definition is balanced and unbalanced load. Balanced and unbalanced load. So first we see balanced, and second one we will see unbalanced load. Okay, so first we will see balanced load. Okay, now diagram देखते हैं पहले. This is A, this one is B, and this is C. Okay, this is R, JXL, so it is ZL of RL plus JXL. Similarly, this is RL, JXL, RL, JXL. ठीक है. Now, if you see, this is the A phase, that is ZA equals to 3 plus J4. Similarly, we are having here ZB is equals to 3 plus J4, and similarly we are having ZC is equals to 3 plus J4. Okay. Now it is in complex or rectangular form. If you see, it is in polar form. It is 36.86. Okay, 36.86. Similarly, 5 magnitude 36.86. Now, what is the meaning? A load is said to be balanced. A load is said to be balanced when it is having same resistance and inductance in each phase. This is the first point or first definition. Now, a load is said to be balanced when each phase is having same magnitude and angle. Second one. Now, a load is said to be balanced when each phase is having same magnitude, and they are also having same x by r ratio. Why same x by ratio? I will tell you. So Z is equals to your r plus jx, then it is mod z is equals to r square plus x square, and phi is equals to tan inverse x by r. And tan inverse x by r means what? Same angle. So a load is said to be balanced when each phase is having same magnitude as well as same angle or same x by r ratio. So it is the definition of balanced load. So देखते हैं definition क्या लिखी जाती है. A load is said to be balanced. A load is said to be balanced when each phase is having same magnitude and angle. This is the first definition of the balanced load. It is the definition of a balanced load. ठीक है यहाँ तक. Now, if you want to improve your definition more, a load is said to be balanced. A load is said to be balanced when each phase is having same magnitude and same x by r ratio. Okay, so a supply is said to be balanced when each phase is having same magnitude as well as angle or same x by r ratio. So example of balanced load is ZA equals to 5 angle 36.86, ZB is equals to 5 angle 36.86, and ZC is also equals to 5 angle 36.86 degree. ठीक है यहाँ तक. So this is the example of balanced load. Hopefully ये बात समझ में आ गई होगी अब आपको. Done. Now we define the unbalanced load. So a load is said to be unbalanced when each phase is having either different magnitude or different angle or both. So let's define the unbalanced load. I think ये clear हो गई होगी ये बात. Now a load is said to be unbalanced when their magnitude or angle are different. A load is said to be unbalanced when their magnitude or angle or both are different or both are different. Okay, or in short we can say magnitude different, magnitude different, and phase angle different, or different XYR ratio. Different XYR ratio. ठीक है यहाँ तक? Hopefully ये बात समझ में आ गई होगी. Now let's take an example. Suppose your ZA is 1 plus J1 and its magnitude is what? Root 2 angle 45 degree. Similarly, I am taking ZB equals to 3 plus J4 whose magnitude is root 5 angle 36.86 degree. Now I am taking ZC is equals to 4 plus 3J J3 whose magnitude is 5 but angle is 53.13. So check. Magnitude different and angle are also different. So it is called balanced supply. It is called unbalanced load. Unbalanced load. Hopefully ये बात समझ में आ गई होगी. So this is about the balanced and unbalanced load from अगर इससे पहले की लेक्चर बात करें तो हमने देखा था बैलेंस सप्लाई और अनबैलेंस सप्लाई. नाउ व्हाट इज द व्हाई वी आर टॉकिंग अबाउट द बैलेंस थिंग्स. सो देयर इज सम एडवांटेज ऑफ बैलेंस सप्लाई. लेट्स सी व्हाट इज दिस. ओके, now advantage of balance system. Advantage of a balance system. Now what is the advantage of balance system? I just take one example then I will tell you. So this is plus minus VAN, that is 200 angle 0 degree. Similarly, I am having another phase voltage also. Okay, now it is VA, this is A, this is B, and it is minus plus, it is BBN is equals to 200 angle minus 120 degree. And this is VCN is equals to 200 angle plus, it is minus, I take here 120 degree. Okay, now I'm having also this three-phase balance load. I'm having three-phase balance load. Okay, just wait on. Done. Then we will have, I'm having A phase is 4 ohm. Okay, then we will also having the phase B, it is phase B, and this is phase C. Okay, so let's draw the diagram. I just want to connect this thing. So it is C phase is connected with C phase, and I just want to connect B with B. Okay, now your RB is also 4 ohm and your RC is also 4 ohm. Now it is, I can represent it at 4 angle 0 degree, 4 angle 0 degree, and RC also can 0 degree. Okay, now so if you apply the KVL here, KVL to this loop, okay, then this is your IA. That is also called line current or the phase current. So if you apply the KVL, VAN minus IA into R is equals to 0. From that, IA is equals to VAN upon R. Okay, so it is 200 divided by what? 200 divided by 4 angle 0 degree. So it is what? 5, it is 50 angle 0 degree. Now, similarly, if you take the KVL for the B phase, this phase, Then your the V phase current IB is what? 50 angle. How much it is? Plus 120. Okay. Because no, sorry, minus, because resistance is having no angle. Okay. Similarly, you are having IC as 50 angle plus 120 degree. Okay. Now, if you draw, this is a balanced three-phase system. I'm just writing it is a three-phase balanced system. Three-phase balanced system. Okay. Now, its equivalent diagram. Its equivalent diagram is this. It is VAN, it is RA, and it is IA. And IA is what? 50 angle 0 degree. Okay. And your V is what? 200 angle 0 degree. Okay. Now, if you see, in this circuit, we are applying KVL 3 times. KVL 3 times. Ohm's law 3 times. Okay. But when you express your three-phase balanced circuit into per phase circuit, because it is a per phase circuit, per phase circuit, per phase circuit. Okay. Now, what's the meaning? Now, if you draw your three-phase balanced circuit into a per phase circuit, then your circuit complexity reduces. We can reduces the number of KVL, KCL, as well as the Ohm's law. And from the per phase circuit knowledge, you can have all the three-phase knowledge. Like, suppose your first phase, the A phase current is 50 angle 0 degree. And what is the condition of balance system? For the balance system, magnitude are equal and angle are 120. So your IB is what? IB is what? 50 angle minus 120. IC is what? 50 angle plus 120. ठीक है यहाँ तक? Now, so I just want to tell you what is the advantage. Okay. So when a three-phase balance system is shown with respect to a per phase system, your circuit becomes very easy. Your circuit becomes very easy, and the number of equations that we have to apply in a balance system are reduces, and it gives the complete information about a three-phase circuit. So in general, all the three-phase system, all the balanced three-phase system are shown by per phase system, and all the formulas, derivation are done on the basis of single per phase system. And in your power system, all the single line diagram or the one line diagram are the per phase diagram, because in three-phase system, transmission system, generating system or distribution system, we are assuming that all the phases are balanced, and for three-phase balance system, we are taking the assumption that it is per phase. Okay, so it is much better to have per phase circuit analysis. Okay, and if you see your three-phase synchronous machine example is drawn with respect to per phase, your in power system single line diagram, the one line diagram are per phase diagram. Okay, because while drawing the three-phase system or three wire three-phase load, it takes much time. It is complex. So all this complexity is reduced by per phase system. So in general, all the three-phase balance system are shown by single phase system, because it reduces the complexity of the network and it gives complete information about the three-phase system by having only one phase system knowledge. Okay, so this is about the balance and unbalanced load and advantage of three-phase system showing by is per phase system. Now let's take the third part of this system, phase sequence of the three-phase supply. Let's see. Let's take the fourth definition of the three-phase definition part. So fourth part is what? Phase sequence. Phase sequence. Okay. So I will just take first example, then I will tell you. So in VAN is V angle 0 degree, VVN is equals to V angle minus 120 degree, and VCN is equals to V angle plus 120 degree. Similarly, I'm taking the next part of this. This VAN is equals to V angle 0 degree, VVN, sorry, I'm just taking here what VCN is equals to, okay, just wait. First we will draw the diagram for this, then we will take, okay. So here I'm just having, this is VA, this is VB, and this is your VCN, okay. Now I will just take the concept of these two, then we will draw. It is VAN equals to V angle 0 degree. Now it is VCN equals to V angle minus 120, and it is VBN is equals to V angle plus 120. So I'm just take this thing. VCN is equals to V minus 120 degree, and VVN is equals to V angle plus 120 degree. Now let's see what are the phase sequence. So first I will define the phase sequence, then what is type of phase sequence and what is the importance of phase sequence. Then after the see we will one numerical on that. Okay. So first part is definition of this thing. Definition of phase sequence. Now phase sequence is the order or sequence. It is the order or sequence that tells you in which phase the first maximum voltage is induced, and after that in which phase the maximum voltage or current are induced. So it is the order. It is the order or sequence. It is the order or sequence in which phase voltage or current attains their maximum value. Let's define again. So it is the order or sequence in which the phase voltage and current are attain their maximum value. So if you see in anti-clockwise direction our phasor is rotating, then the first movement, then the second movement, and the third movement. So according to this phase sequence, A phase gets first maximum voltage, then B phase gets maximum voltage, then C. So for this C, the phase sequence is A, B, C. Okay. Now for this, if you see the second diagram, in A phase first maximum voltage is induced, this is 0. In first phase, A phase maximum voltage is induced. After that in C phase, and after that it is in B phase. So in this the phase sequence is ACP. Just mark it. It is ABC, and so phase sequence is the order or sequence in which the phase voltage or current attains their maximum value. Okay, now phase sequence is of two types. Positive phase sequence, it is called positive phase sequence. It is called and it is called negative phase sequence. Okay, negative phase sequence. Okay, so we just first define the definition of phase sequence, then what is the meaning of that phase sequence and diagram. Now how we can convert a phase sequence from negative to positive. So phase sequence can be reversed by, first thing, phase sequence can be reversed by changing any two terminal of the coil or phases with respect to your reference. See the diagram. If you flip these two, here it is B, here it is B, like that. you are having, it is B, it is B, sorry, it is C and it is B. If you just flip these two, flip these two, then your phase sequence is reversed, because here phase sequence is ABC, but here the phase sequence is ACB. So phase sequence, next part अगर हम देखें इसका, so this is the first point of this. Second point, phase sequence can be reversed by interchanging any two coils with respect to reference phase. Okay, so this is your example where this is ABC and you just flip your B and C, you will get a reverse phase sequence. So this is the second part. And third part is what? Type of phase sequence is what? Types of phase sequence we discussed. Types of phase sequence is what? It is of positive phase sequence, and it is negative phase sequence. ठीक है यहाँ तक. Now, what are the important in fourth point? We will see the application or the importance of phase sequence. Importance of phase sequence. Okay, phase sequence. Okay, now when your three-phase generator or your three-phase transformer are connected in parallel, to have the perfect or ideal or exact parallel operation, the phase sequence of generator or transformation should be same. Otherwise, they don't operate in parallel. So these are operated in parallel operation. In parallel operation of three-phase machine like alternator or in three-phase transformer, in parallel operation of three-phase machine like alternator or three-phase transformer, we have to check phase sequence. So it is a condition of parallel operation. Okay, now next importance, if you see, when a fault occurs, a voltage becomes unbalanced. This unbalanced voltage is resolved into three component. What they are? They are the positive sequence component, the negative sequence component. It is negative sequence component, and the last one is zero sequence component. Zero sequence component. ठीक है यहाँ तक. So suppose आपके जो वोल्टेज है VA, VB और VC किसी सिस्टम में, और वहां पर कोई फॉल्ट होता है, then they are resolved as VA1, BB1, VC1, then VA2, VB2, VC2, and it is VA0, BB0 and VC0. Okay, now the positive sequence component are shown by the phase sequence of the supply phase sequence. I just draw this. It is VA1, BB1 and it is VC1. but the negative sequence component of the supply voltage or current are opposite to the supply phase sequence. That's why it is VA2, it is BC2 and BV2. That's the meaning of this signal. So when you study your fault in power system, it requires the knowledge of phase sequence. It is ABC and it is ACB. But your zero sequence component has no phase sequence because they are co-phasor component like that. VA0, VV0 and VC0. So for parallel operation and for your fault study, you must have a knowledge of phase sequence. And let's see the one numerical on that so that you can have a clear picture of phase sequence. Let's take a numerical on that.